to thank you all for joining us today for this month's Best Practices webinar. And I'm really pleased to have with me a very special guest, and that's Gil Acosta, who, at least as of this week, is the Director of Engineering Services at eMaint Enterprises. And he's going to be presenting today's topic, Understanding World-Class Performance Metrics. And I'd like to start, as you see on your screen, a little bit about Gil's formal background. He is an engineer. He has his bachelor's in metallurgical engineering and a master's in engineering management, and over 30 years experience at Fortune 500 companies in production, quality, project management, and various engineering roles. But what's particularly interesting about Gil, I believe, is his background with eMaint. And some of you are no strangers to Gil, but you may not know that his relationship with eMaint goes back to 2007 when he was searching for a CMMS system at one of the Fortune 500 companies he worked for, a leading manufacturer, and became a client in 2008. And my personal experience with Gil began in 2010 when he was visiting eMaint, and you know, I guess for those of you who are also engineers out there, you're all about continuous improvement. And one of Gil's suggestions to myself and the marketing team was, you know, it's great when users can get together with other users and share ideas and learn from each other. And for those of you who have been to our user group summit and some of our conferences, that was actually one of Gil Acosta's ideas, and one of his continuous improvement projects for eMaint was to help us kind of launch those. So it's always really a pleasure to work with Gil. He also, a little bit about today's session, Gil has been a consultant for the past year or so and was actually a guest speaker at our conference last November on a very similar topic on metrics. And it was one of our most popular sessions, and that's what prompted us, you know, and you spoke, we listened, and that's what prompted us to really invite Gil to present today. He's recently, as I mentioned in the last few weeks, joined eMaint full-time as Director of Engineering Services, and we'll talk more about that at the end of the session. But right now, without further ado, I would like to introduce Gil. And maybe, Gil, while we have a very large group today, and while people are logging in, can you just take a minute and tell us a little bit about this topic, what kind of inspired you to put together today's presentation, and why you're so passionate about it?
Thank you, Rona. So welcome, everyone. As Rona has told you, my name is Gil Acosta, and I have just started as the Engineering Director for eMaint. So what brings me to this topic is, over the course of my career, if I learned anything, I learned that the language of business is to be able to have metrics to speak to performance, speak to whatever the case might be, you know, cost per unit kind of thinking. And it struck me as I was working in my various job roles that probably the key reason that you even launch a CMMS initiative is because you want the data. And you want the data so that you can draw information from the data to make business decisions. It's not just about launching a software platform for the sake of a software platform. So certainly CMMS systems help with organizing work. They certainly help with managing large volumes of work orders and call-ins and breakdown tracking and so forth. But at the end of the day, when you really think about it and you collect all that information, aside from making sure the work gets done, it's really about the data then that you can mine to try to make decisions on your business. So it's brought me to this point where, you know, it's interesting how paths tend to cross. As I ventured out on my own as a consultant, and I got invited to be the keynote speaker at the user conference in Estero, this was a topic that Ron and I kind of felt might be the most popular, and certainly it turned out to be. And it really is because of the passion that I feel about getting the data. If you don't have data, then it's just an argument. It's just a debate. And without the data, the most senior person in the room wins. So trying to stay out of that kind of a situation then for me was why you want to help people be able to get the most out of the CMMS systems in terms of what data am I able to extract and what information am I able to pull. And I've seen just some wonderful case studies, some of them on my own personal one, some of them have been shared with me. And so this session is really about how do you think about metrics, how do you get your brain and your organization organized around thinking about metrics, and hopefully you'll find it useful, and if there's anything I can do to help you with continuing the thoughts or developing further, it's certainly an opportunity to reach out. So with that, let's just jump right into the topic. These are essentially the things that I will cover for you, why we need them, how they apply to maintenance, how do you get started? Sometimes it's easy to decide that it's the right thing to do. It's a lot more difficult on actually getting going. And so we'll talk a bit about that. There are certainly some metrics within the eMaint environment that are very easy to extract, provided you set up your system correctly. And then there's the whole concept of what's next, beyond just collecting metrics and making judgments about performance and business decisions. There is kind of a roadmap to this, and we'll talk a little bit about that. And there'll certainly be time at the end of this session for some Q&A. I'm going to target kind of wrapping things up with it no less than 15 minutes at the end to kind of have a question and answers as needed. So right out of the gate here, I'd like to ask everybody on the call, just to answer this question: do you currently get automated metrics out of your CMMS? And the choices are there for you to think about. The yes, I put a caveat. I have everything I need to tell my story, because that's really what I'm talking about when we talk about metrics. Do the metrics tell the story of your organization in order to help you justify or for that matter, even secure funding on where's the next area of improvement? Somewhat means then I have a few data and a few metrics that I'm able to pull, but it doesn't tell my full story. And of course, no, I don't have a CMMS structure to extract metrics. And then, and of course, the fourth choice there is I do not have a CMMS. And if I could just see a poll, it'll kind of help me gauge some of the points of emphasis here. So, Rona,
Sure.
if you'll launch the poll.
Yeah, so I'm launching the question that Gil is asking, and please just type your responses right into your keyboard, not into the questions feature, and let Gil know so he knows who's on the line with us. Where are you today regarding your metrics? Your yes, you have everything you need, or, well, you have some information but not the full story. No, I don't have my CMMS structure to really be able to get at the metrics, or maybe you don't even have a CMMS. So tell us your position regarding your metrics and the CMMS. All right, I see we have about 80% of the votes in. And again, type right into your keyboard, and we'll share the results shortly. All right, it looks like everyone has voted. So let me go ahead and close this poll and share the results. All right, Gil, so what we're finding is 5% say, I've got it all. I've got everything I need to tell my story. The rest of us are very envious. 43% said, somewhat. They have some data, but it doesn't tell the full story. 28% says, no, I don't have my CMMS structure to be able to get at the metrics. And 24%, about a quarter, say, I don't currently have a CMMS. All right, okay. So I'm going to hide that, Gil, and back to you.
All right, thank you, Rona. So I appreciate the quick responses. So that kind of tells us where we kind of stand, and that'll help me structure some of my comments. And so let's start off with, why do you need them? There's a whole lot of good evidence out there, but I sometimes like to just capture good thoughts, quotes from others. And the first one is from James Harrington. Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. I think that's a wonderful summary statement of why we want to have metrics. It really is, to my point earlier, if you don't have data, if you don't have metrics of performance, you really are just having a debate of opinion. And oftentimes that debate of opinion is not won by the most logical debater, but oftentimes by the most senior person. A corollary to this I thought that I came across was out of a Harvard Business Review. And it was interesting the way it was structured. It simply said, it can't be that simple. You might argue, but psychologists and economists will tell you it is. Human beings adjust behavior based on the metrics they're held against. Anything you measure will impel a person to optimize his score on that metric. What you measure is what you get, period. And I think I've seen this behavior in factories. I certainly know it drives our executive teams to perform based if their bonus is being driven by a metric. I think almost everybody will have a story to tell where they've seen sometimes bad behaviors because of someone trying to improve a metric, and even though that was never the initial intent of setting up that performance measurement. So there's certainly a care that comes with picking your metrics. But I think these two quotes here tell the story of, just in a simple nutshell, why we want to have them, why we need them. As human beings, we strive to improve, we compete, we want to have the best score. And if you don't tap into that energy, then you're missing a golden opportunity to improve your organization. In the environment of maintenance, then, there really is kind of, in my mind, a progressive hierarchy, so to speak, a roadmap. And I honestly believe that you need to follow this general thinking in order to achieve the best results. So what you're looking at on the slide here is just kind of my depiction of what that progression is. It starts out with frequency histograms. It moves up to mean time calculations. It moves up then from there to condition monitoring, and then ultimately you get to predictive algorithms. Now, the point behind this is that you can't, every one of these is progressively sometimes more expensive, whether in terms of how you collect the data from your labor force or whether there's automated collection systems that you set up. So you certainly don't want to start at predictive algorithms and try to go apply this to all the equipment in your factory. I think intuitively most of us know that that's kind of crazy talk. This progression then is about the cheapest and easiest thing you can do with a CMMS system is develop frequency histograms. You know, this is what's the top 10 things that are going on in my factory. Which asset has the most interruptions? Which asset has the most unplanned events? Which department struggles with the most downtime? Who has the most emergency breakdowns? These are all forms of and types of frequency histograms. You move up into your mean time calculations, where in a hierarchy of structured assets, it sometimes starts out with looking at the parent assets and knowing what's my mean time to failure, what's my mean time between to repair, what's the mean time between interruptions. One area that I've certainly come across and share with this audience is that the mean time between failures and the mean time to repairs are fairly common metrics that we've all heard or read about. The mean time between interruptions I define as those that are not about unplanned events but planned. I have actually some very good case studies where the biggest detriment to the factory and to the production line was the number of PMs that we were performing on equipment. See, those won't show up on a mean time between failure or mean time to repair because they're not unplanned events. And I've certainly come across where the thinking, the school of thought was that, you know, the more PMs, the better. But there are certainly case studies where that's absolutely not true. And sometimes the best thing you can do for your factory is to stop performing certain PMs. Now, there's a fair amount of data analysis that's required before you go off and do that. But certainly what you're looking for is if my PM program is not reducing downtime, then one, am I doing the right PMs? If I think I'm doing the right PMs, am I doing them correctly? And if I think I'm doing them correctly and they're not making a difference, then why am I doing them? And so that would be your mean time between interruptions. Of course, condition monitoring then gets a little bit more expensive because now we are collecting data, we're analyzing data before we determine a condition. These are things such as thermography, acoustic emission, vibration analysis. There's certainly some money and effort spent to even collect the information, to have the right equipment to do it. And of course, if you take it to the next step and go with automation, automatic data collection that is, then it's even more expensive than that. And so the only next step up from there is that predictive algorithms are taking the condition monitored data and running it through a series of calculations. Maybe you're more interested in the slope of temperature increases than you are with the actual temperature, and so you're calculating slopes, or you're calculating sinusoidal waves for acoustic emissions, and simply trying to make a determination, is that a predictor of imminent failure? And so this is why certainly that's another level of work and investment, and this is why you want to start with the cheapest things you can do first, and let the data guide you on what is the probably the most cost-effective means in your factory. I've seen factories with literally hundreds of assets, maybe thousands, and only one or two critical pieces of equipment will have any kind of condition monitoring on it. And that to me is an intelligent way of addressing where am I going to spend my money. In every organization throughout the world, maintenance is seldom thought of as an R&D environment. It's not thought of as a research and development. That means it's sometimes not thought of as an investment. It's thought of as an expense. So if I have a limited pool of money to spend, by the time you're talking about condition monitoring and predictive algorithms, you're really talking about selectively spending my money on those things that I think are going to be the biggest bang for my buck. And so this is why I'm particularly pressed upon clients to follow this roadmap. Let's go do the cheap and easy things first. I can probably generate frequency histograms at almost no cost to the organization, provided I've got a CMMS system, and then we'll progressively move from there. I honestly believe that if you skip a level, you will probably not achieve the fullest results, and you will probably spend unnecessary expenses. So where do you begin? One of my favorite sayings, if you've met me before and you've probably heard me say this, is start with the ends in mind. What does success look like? Define it for yourself. There is no cookie-cutter approach to this. There is not a set of metrics that I'm going to say this is what every factory, world-class factory runs, and this is how you should run them. Every factory is different, but in many cases every factory is the same. You're trying to produce a quality product or a quality service within a reasonable cost and profit margin, safely with consistent quality. And so what does success look like? Well, if I was sitting in your office and talking to you, I would ask you what data reports would make your life easier? What information does your boss consistently ask for? What is your current PM to CM ratio? Because if I know this, I know areas where I want to focus. If I see a very low PM to CM ratio, I know that you have a lot of unplanned conditions. We're going to focus our metrics and performance values to go look at these breakdown conditions. Where are they occurring? What's driving them? What's the mean time to repair? What parts are being consumed? If I see a high PM to CM ratio, I may actually be concerned that maybe you're doing too many PMs. And you're maybe interrupting the production flows and causing other problems from that. You have to ask yourself, if you're going to monitor PM-CM ratios, then what is the PM-CM ratio does your business need? A pharmaceutical industry certainly needs a different PM to CM ratio. A hospital needs a different one. An automobile factory would certainly be different. So you really have to understand your business to know what's important to us. Where's the point of diminishing returns for my organization? And so I would not necessarily profess to you a particular PM-CM ratio without knowing what your business requirements are. And another one to think about is, what are your current maintenance budget busters? So anybody in the maintenance organization will probably, if I go in and just ask these few questions and then ask them, which one breaks the budget? Which is that surprise line item every quarter or every year that consistently kind of sneaks up and bites us? We don't know when it's going to occur, but we just know it's going to occur. And one of the leading indicators is how good is your on-time PM performance. If you've really done your work and you've decided that we need to perform a PM, this is what I tell folks is the equivalent to, we know we all need to change the oil in our automobiles, or they're eventually going to break down. So some automobiles require changes at 4,000 miles, some require them at 5, some at 8. All right, whatever your PM performance is, if you said it needs to be changed at 8, do you change it at 8? Or does it become 8,500 miles or 9,000 miles? If you need to change it at 4, are you doing it on time in order to ensure that you're getting the best possible benefit of that PM? It's surprising to me that when I go into a factory and we first turn on PM performance compliance, I always like to ask the question to the folks in the room, what do you think your performance is? What does your gut tell you if you're not already collecting this data? And intuitively, people feel that they're doing pretty good. And I get numbers, I think we're probably 80%. I think we're 90%. I've turned on this PM performance compliance metric in certain sites, and lo and behold, it's running 50%. And we have PMs that have been open far beyond what anybody would have reasonably said was okay to still be pending. So, it's one of those things, you don't know what you don't know until you have the data in front of you. This little list here is just to get the juices flowing, to get you thinking. These are generally fairly simple to go out and start collecting. Oftentimes, if I find a client that really hasn't put a lot of thought into their metrics, this is a great starting point. Because what will happen is from this basic set of metrics, it'll start to drive more business savvy metrics for you. So it's not a one-time thing. If you get a message from me on this slide, it's kind of a journey. It's a progression. And maybe frequency distributions start you out, but they're not going to take you to the performance ultimately that you're looking for. So you may start up with a top 10 analysis process, and very quickly you move to some critical equipment being monitored in your mean time analysis, and then from that very quickly you may justify condition monitoring. And so every piece of equipment, every asset in your factory has a story to tell, and part of our jobs as maintenance professionals is to try to go extract that story and make the best possible business decision for the company. Your lagging indicators then are what you see there, your mean time analysis, your top 10s. Your leading indicators become things like PM on-time compliance, estimates versus actuals of any type, percent failure undergoing root cause analysis. So just as another little test, having heard what I've had to say to this point, Rona, if you'll get ready to launch this poll question, what are the following metrics do you currently monitor or track? Certainly I know some of you folks don't even have a CMMS, so the answer is going to be none. But for those of you that do have CMMSs, what are some of the things that you're currently looking at?
Great, okay. So if you want to go ahead and type your responses directly into the keyboard and let us know which of these metrics are you currently monitoring, even if it is manually. Do you look at your corrective, or the CM versus the PM, corrective versus planned, as Gil alluded to? Or are you doing some form of mean time analysis, either between failure, mean time to repair, between incidents, etc., or interruptions? Or do you run some top fill-in-the-blank reports? What are your biggest, where are you spending the most money, what's occurring the most frequently, what's taking up the most of my time? Or are you looking at on-time compliance? And by the way, you can respond with many. We just like to get a feel for which of these type of analyses is our audience doing today. Or are you looking at the percentage of your failures which are undergoing some form of root cause analysis with your team? All right, so go ahead and tell us which of these different types of metrics you currently take a look at today. Again, it's just to share information and see who's with us today. All right, looks like we've gotten just about everyone who responded. So let me go ahead and, a couple more. All right, I'll give you a few more seconds. All right, let me share the results now. So it looks like, Gil, just over half, 51%, say they're looking at their corrective or CM versus PM. 23%, or almost a third, say they're looking at some form of mean time analysis. 36% do a top 10 analysis. 2/3, that's the biggest one, are doing PM on-time compliance. Excellent. And then only 9% say they look at the percentage of their failures that undergo root cause analysis. All right, Gil, back to you.
All right, thank you. So I appreciate that. So great. So it sounds like many of you are already well into your journey. So hopefully what you'll see then is that this will stimulate the thinking about where else can I look. Right? If I'm already doing top 10s, is there some mean time analysis that could help supplement that to give me a better picture, to get to more fully tell my story, and to and ultimately what I tell folks is I was always trying to tell that story because I was going to use that story to justify my next investment. So there's two schools of thought on maintenance. You spend as little as you can, or you spend as much as you can. And I was of the school as you spend as much as you can that doesn't break the business. Because what I want to do is I want to have a budget that says, let me spend on investments that give me better performance. It's not spending for the sake of spending. I don't just need a new shiny truck because I want a new shiny truck. I may invest in a better quality motor or fan system or HVAC system simply because I expect to get returns. The returns are either measured in savings or improvement to quality, or in some cases both. But the ultimate improvements you're looking for is improvements to throughput. What does 5% more production output mean to your factory? If you don't know that number, or if you don't have a sense of what it means, then it's really hard to think about maintenance as an investment. It's always going to be thought of as an expense. But if you think about what 5% more throughput would mean, and in some of your factories, it's got to be, and could even approach millions of dollars of impact to revenue. Wow, why not spend 25, 50, 100,000 a year in investment type maintenance activities that try to squeeze out that extra 5%, or that at least ensure we hold the gains? So that's the thought here. That's the stimulation behind it. This is why I feel so strongly about these things, because I've always felt, and to this day, and part of what I hope to bring to eMaint's client services here is the ability to have those conversations with like-minded professionals that are interested in how can I make it better. It's not just about holding down cost. It's about making things better. And in the course of making things better, I do get a better cost to revenue ratio. But I might be spending more now than I was spending in the past. But how many of us wouldn't immediately sign up for an exchange of $50,000 for $500,000 of revenue? It becomes a no-brainer at that point. It's the data that helps you tell that story, as opposed to all the fist pounding on a table and opinions in the room. So as we talk about, okay, what do you got to do? And we talk about, okay, I'm sold, Gil. I want to do more with metrics. Where do I, besides knowing that I want to have some calculations, what do I got to do next? Well, you really have to start out with an asset structure that is aligned to the data collection. So let's talk a little about asset structure. Your asset structure at a minimum should include some kind of a parent grouping, some kind of a child-specific assets. Now, the child-specific assets, in my terminology here, these are the assets that I'm actually going to charge work against. The parents are more about helping me measure performance. It's a grouping. It's a filter. And I don't charge work orders to parents. I only charge work orders to children. Now, in some of your factories, you may actually have a child-child relationship, which is fine. The concept is that you just have to make sure you have an asset structure, and your work orders are being charged at a specific level, but never to the parent. So how do you take care of those miscellaneous things or those random items that you don't have a specific asset to charge against? Simple. You create a miscellaneous asset. just a holding bucket for all those work orders that don't fit against one of the assets in your factory. I always recommend having that, and I also recommend that it's only one per parent. This should not be a crazy setup where you have multiple miscellaneous assets for parent grouping. There should just be one. Now, what you're going to do when you mount it to your metrics, you never ever want to see a top 10 analysis show up as one of these miscellaneous buckets. If it does, then it tells you that there's analysis to be done. You got to go inside that miscellaneous bucket and find out what's happening inside of there, which miscellaneous activities are driving this, and perhaps they merit their own asset, or perhaps there's a quick fix to keeping it from being such a big hitter. But once you have this miscellaneous asset and you do your top 10 analysis, it should never be in your top 10. The second half of this, then, so you have to set up your asset structure to begin with. Then you need to look at the work order form itself, because the work order form is where you're going to ultimately collect your data. So the work order serves two critical purposes. And some of you may call them work tickets, but it's the same thing. You know, it's the orders that you issue for somebody to go do the work. On the front end of the process, or the work order, the work order defines the work that needs to be done. It should have the child asset as a mandatory field, because I have to charge this work to some asset. The parent asset information can auto-populate, because once I know the child, I know everything I need to know about the parent, because it's always there. I want to know what work type I have, whether it's planned or unplanned. You can have subcategories to that. I've seen factories have lower levels of work type, but at the very top level, I want to separate things into just two buckets, planned and unplanned. And all my planned activities roll up under planned, and all my unplanned activities, be it emergencies, call-ins, repairs, you name it, they roll up under unplanned. Work status, open, close, your primary craft that's responsible for getting the work done. This primary craft is the person that's ultimately responsible for the quality of the work. There can be many crafts that work on this job, but I at least want to know who signs off. So if I have to come back and investigate, I want a name. I want a single point of contact that explains to me what happened on this work order. Now, on the front end, when you're assigning, you don't necessarily have to assign by name. You can assign by craft. It's on the back end when you close it that you want to know who actually did the work. Then a few other things like required other crafts and hours, materials needed, safety information, due dates. These are all part of the upfront planning of the work. Then the second part is to capture what work was actually done, and the actual labor that was used to perform that work, and the date that the job was actually completed. I can't tell you how many times I've gone and had discussions with organizations where you look at their work order, and I ask them, so what does the date mean? And people will want to interpret that date to mean many things, but ultimately you find out that it means the date that the job was printed. It has nothing to do with the day that the job was actually performed or the day that the job was actually identified. And so you have to be cautious. Their date can be a little bit misleading. There's no way to do this with a single date. You have to know, first of all, the date that it was printed and planned is probably the least important of the dates. You want to know when the work was actually done. You want to know the date that actually the work was due, so that you can compare against lateness. And then you also want to know when it occurred and how long it took, and so that may be 2 or 3 or 4 timestamps to get all that. You want your crafts to be trained to make any comments on significant deviations, right? We don't need them. We need to waste their time for them to write up everything, especially if it was routine. But certainly anything that was a significant deviation should be written up. You want to absolutely know the parts that were consumed. You know I needed 4 quarts of oil, but I used 5. You know, and the next time I do the job, I needed 6. Well, very quickly I start to realize, hey, I'm spilling oil somewhere. I'm consuming or burning oil in an area where I wouldn't expect that. And of course, problem codes are just another means of having categorizations that help you focus on the problem and prioritize and identify. This is kind of bare minimum. Some of you probably have many more fields on your work orders than I've listed here, but what I'm trying to just convey to everyone is you have to go through the thinking of capturing the information. First of all, you want to be able to tell the worker what to do and how to do it properly, and then you want to capture the actual work coming back, because the actual work coming back is where the data comes from to drive some of these metrics for yourself. Ultimately, we're looking at how to think and plan our work, and the PF curve is, for some of you that have not seen this curve, it really it's a concept that helps illustrate predictive failure versus actual failure. And I'm not going to read it to you, but it's a nice visual to look at what happens over time, that if you continue to ignore a problem that's maybe starting to be detected, you will eventually get to the point of catastrophic failure. So in my analogy of an automobile, if I don't put oil and it was due at 4,000 miles, does the car break down at 4,001 miles? No, probably not. Does it break down at 5? Does it break down at 6? When does it eventually break down? And when that point is, would be further on the time scale to the right. But the fact that I actually hit a point where it was time, and maybe after I didn't change the oil, the engine started to run hot, but I ignored the fact that it was running a little bit hotter. Then maybe as I ran the car a little hotter, I started to notice that there was a vibration, but I ignored the vibration. Ultimately, I start to hear mechanical damage, and finally the engine seizes and fails. So this concept is that your equipment has telltale signs. Our job then becomes, how do we identify them, and what are they, and how do I move from being in the right-hand side of this PF curve to the left-hand side? Because you'll notice that in the early sections, in the priority 5 and 4 sections, the curve is fairly flat. And so what I'm looking for is I want to detect a possible failure early enough to provide time to plan and schedule without panic, without reactivity, and without increasing costs. What's the increasing cost? Well, I'm going to go in and do the work, so the work is the work. I'm going to consume the parts unless I get the catastrophic failure, in which case I may have a lot more parts involved now. I also don't want to expedite parts, and I also don't want to call in labor on overtime or weekend call-ins because I waited so long. So I want to plan this work with the lowest cost possible, with enough time to get it in the schedule and pick when's the best time. The worst time to figure out that you should have changed the oil is when you're sitting on the side of the highway and you're calling AAA. The best time is to decide, it's time to change the oil. I think I'll get up Saturday morning and make a stroll over to the oil change place and get it done then. So that's the concept that you're looking at here. Your data then is the one that's going to help drive that for you. Now, this slide here is simply to help stimulate the thinking around. Now, as I look at conditions, there's other things besides using my fingers to test whether it's hot to the touch or listening with my ear. There are handheld thermography units. There's fixed position infrareds. There's handheld acoustic emissions. The beauty of what's happening in our industry today is that the cost of utilizing this equipment has come way down. I can remember 20 years ago when you talked about doing a thermography survey, you were talking about multi-thousand-dollar pieces of equipment and a surveillance audit that cost just as much to come and do. Nowadays, any one of your departments can probably own a handheld thermography unit for under $1,000 and just build that into a survey. All you're looking for is accurate enough, right? I don't need to know that the temperature is precisely 2 degrees hotter. I just need to know that it's hotter from the baselines that I've been taking. So these are the type of things that are out there. This is how you move yourself from further up the curve to having more planned maintenance as opposed to emergency maintenance. And these are some of the devices that will help you. So again, back to my point around why it's a progression, I sure wouldn't want to go into a factory with 1,000 assets and start looking at which condition am I going to monitor for each one of those 1,000. I'd rather whittle that down to the top 100 or maybe even the top 10 and just work on those. And once I'm satisfied that I've changed the direction of behavior, in other words, once I've made enough of a difference in the unplanned condition moving to planned, then next year I tackle my next 10, and the following year my next 10. And this is why I say that it's maintenance it's important to think about it as an investment, even though it's very challenging in some organizations because they're always traditionally been thought of as an expense. Use your data to help justify where am I going to spend the small little budget that I've been given to make things better. Where am I going to spend it? Well, I spend it by using my data to help narrow down the choices. Of course, the ultimate thing is to really get into some automated, especially when you have factories that have more geographical footprint than others, and it's very difficult to just do surveillance walkarounds. A simple model that I share with you that eMaint certainly can support. I know other CMMSs can probably do this as well, but certainly within our platform, this is very doable, and in fact, we have many case studies of this. You start out by identifying which asset you want to remotely collect data. You set up the data collection device, and the device is, could be one of those mounted infrared recorders. It could be wireless, it could be wired, doesn't matter. You get that data from that device into a local server. The local server probably runs the algorithm or the condition monitoring max-min levels, and then it sends a signal to your eMaint system that says, oh, I just got a trigger. The slope is exceeded the value that I'm allowed, or the sine wave is greater than I expected, or I'm seeing vibration, or whatever the case might be, and it triggers an alarm, and that alarm goes to your CMMS eMaint system, and the eMaint system automatically generates a work order for investigation, and that work order can then be tracked for completion. What did the investigation discover? Is it really a true condition for repair? Let's plan it. Let's schedule it. Let's go in there and see what's going on, because certainly what you're hoping to do, what you're expecting to do, is not just detect a failure that's about to happen in the next couple hours. You're hoping to detect conditions that give you many days of lead time and sometimes weeks of lead time in order to get that work planned, maybe even get the parts in, maybe even call in the specialist. So this is the progression of metrics, and why I so encourage people to get on the journey, because wherever you start, you're not going to, it's not the end of the story, it's the beginning of a journey, and you will find yourself, maybe months, maybe years later, looking at improvements of the type that I'm currently reviewing on the slide, which is data collection systems. Certainly in my consulting work, and what we intend to do within the eMaint client base is to help our clients kind of vet these solutions out, offer our technologies and our capabilities to put these systems in place. So in summary, begin with the end in mind. What does success look like? Make sure that your asset hierarchy supports that vision. Make sure that the work order has the correct fields to collect the data that help you achieve that vision. Monitor the work order process, right? It's one thing to have the fields on your work order. It's another thing for your field techs and crafts to fill it out correctly. So there's often training, there's often surveillance, there's often reprimands because people turn in work orders incomplete. But there has to be a discipline about making sure that the work orders are filled out properly and returned and closed out. And so you do this by monitoring the work order process. How many open work orders do I still have? What's the age? What's the completeness? And if I can take care of that on the process side, then my data is going to be meaningful and complete, and I'll be able to make good decisions. Once I have those, then I can monitor the asset performance, and now we are talking back about what's the mean time analysis say, what's the top 10 analysis say, perhaps even what's my condition say, what's the type of parts that I'm consuming, what's the cost of PMs for this asset. Oftentimes I'll tell you that it's not uncommon to begin to analyze an asset and to discover that even though that asset is performing wonderfully, I've got really good uptime. But I'm spending an awful lot of time and money on PMs to achieve that. Maybe rather than spend that time and money on PMs, I can invest a little bit more in my asset and save the money of the PM. This is why it's important to look at that mean time between interruptions and also the cost of PMs. So I'm as big about analyzing corrective measures as I am about analyzing preventive measures. They're not cheap, they're not for free, and just because you may be achieving the performance you want in the asset, it doesn't mean that you can't look at the PM requirements and question whether or not they're necessary. And then you prioritize day in and day out. You're always deciding where I got to go next. You know, I've got emergency responses, I've got breakdown conditions, I've got et cetera, et cetera, et cetera. Your data will help you prioritize. You can even put some automation into the CMMS environment for identifying criticality. There's risk assessment factors that you can put into the system that allow you to sort these out almost immediately. And so this is the journey of using data to manage your maintenance programs. And of course, it starts with having a CMMS that's properly structured to collect that data for you. And ultimately, you're moving up that PF curve, trying to get things further to the left so that I can plan and stay away from the right where things fall off the cliff, and eventually I've got catastrophic breakdowns where I have excessive amount of overtime, excessive amount of expediting. One of the metrics that I've always liked in certain organizations, they monitor their freight, and if freight is going out the window, is starting to get too big, it's an indicator that we've got too much exception activity. And in fact, you can even take freight and break it down into other categories such as expediting freight, overnight deliveries, things of that nature, and it starts to tell the story of where to go look. So thank you for your attention. I appreciate the poll questions and the responses. I hope this has been helpful for you. Again, this was not a how-to session, but really more about stimulating the thinking for you to start your own journey or to continue the journeys that you're on. Certainly by the polls that we had, it was clear that many of you are well on your way.
Excellent. All right. Well, thank you, Gil. And so for our listeners, this is our Q&A period, and Gil has been kind enough to stay through the hour and answer the questions that you might have. And again, just please, we're recording today's session. We will share a link to the recording with all of the listeners today. And if you would like to get a copy of the slides, there'll be a brief poll at the end. I'm sorry, not a poll, but a survey at the end of the webinar, and you can indicate if you'd like to get a copy of the slides. But in the meantime, we'd like to open up the floor to those of you who would like to type in a question. And a few, Gil, that came in during your discussion. Do you have any tips for motivating tradespeople in documenting their work completely so that the data you collect is accurate? You did talk about the importance of capturing that right information, and what can you offer from your experience that might help motivate the people completing those work orders to get the information right?
Excellent question. I'm chuckling to myself because it seems like one of the challenges in any organization I ever step into is how do you get the craft folks to give you back the information? And this is generally a group of people that are not, not looking to write books, not wanting to communicate easily, and just let me do my job, right? I got my tools. I know what's broken. I'll fix it. And my favorite work order feedback is I see work orders where it says problem, broken, solution, fixed. So I'm sure some of you have seen work orders just like that. So my tip is this. First of all, it does start with some training and awareness, helping the craft understand why it's important to give information better than just broken and fixed. But aside from that training and awareness, one of the things that I always like to do is I like to create work orders as much as possible where all the craft person has to do is check a box. So there's a list of options without getting too crazy. You never want to have a craft person who sits there and tries to decipher which of these 100 choices am I supposed to check off. But, you know, simply just 2 or 3 check boxes say this, 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 and this, and then the only time I'm asking them to write anything back to us is in the comment field, and the work order has a space for comments, and you simply ask them to tell me only exception activity. If it's routine, check the box that it was routine, and I'll assume there was nothing out of the ordinary. But if there was something out of the ordinary, please tell me about it in whatever words you want. I don't care if it's just 3 or 5 words. It'll be a history record that'll allow me to go back and talk to that craft person about what exactly happened that was out of the ordinary. You know, so even a checkbox that says nothing out of the ordinary is fine, because at least it communicates back to the work order history that there was nothing out of the ordinary. The worst thing is blanks. Blanks don't mean anything, right? Some people want to interpret blanks as no problem. I've learned to think about blanks differently. Blanks just mean no information. There might have been huge problems and no one told you about them. There might have been something else mitigating and it's not captured. So I've had very good success with taking work orders that had a lot of handwritten notes, handwritten information, handwritten part numbers, and try to do as much as possible with pre-populating these onto a form, and then it allows the craft person just to check off the box. And boy, they're more than happy to spend 2 or 3 minutes. They're generally not happy to spend 15.
Great. Those are helpful tips, Gil. We have a couple of questions around PM completion, and is there a way to use that for justifying additional maintenance staff? And I'm gathering from this question, as you look at some of these metrics, can some indicate to you that you might need to look at your staffing levels?
Absolutely, absolutely. So in fact, I believe that when you're doing PM compliance, it really is looking at about resource planning. So what tends to go hand in hand with your PM compliance is the analysis that looks at why am I not compliant. So if I'm hoping for 95% on-time completion of PMs and I'm achieving 80, oftentimes the gap, explaining the gap and gathering the data on the gap is where the story is. And many times the story goes like this. These people are not idle. These people are busy fighting fires. They're responding to emergency calls. Here's the data of how many emergency calls I have. I can't get out of this vicious cycle because I'm too busy cleaning repairs and emergency call-outs because we don't keep up with our PMs. Once you convert that to the dollar impact, because it's not hard once you have your unplanned data and your planned data segregated, it's not hard to tell what the average cost of unplanned events are versus planned events. You can even do it per asset, right? So if you really are looking at a group of assets, say for example, I have a client who was having trouble with gearboxes. If I looked at planned gearbox maintenance and I look at unplanned gearbox maintenance, my guess is that it's going to be significantly higher in the unplanned environment. There's now the dollar value that helps me justify what's it going to take to get a PM program on my gearboxes that keeps them from becoming unplanned events. So it's not simple, right? The CMMS doesn't solve that for you, but it hopefully is the tool that you're using to collect the data to be able to answer and tell the rest of the story. But I think it's a wonderful tool for helping justify resources. In some cases, to break the cycle, you have to have a dedicated group of people that deal with PMs, and you have a dedicated group of people that only deal with emergencies. Oftentimes, I've seen some clients go to the extent of hiring outside contract services to handle PMs, so that there's no way that they can get sucked into the repair categories because they're not trained, they're not authorized, they don't have the wherewithal to go do that. So you hire a local service to just come in and take care of all your greasing, and they write a report at the end of every day of all the greasing jobs they completed, and you just kind of close out those work orders and you're done. Maybe another service provider takes care of your engine oils and your fleets or your utility vehicles or checks batteries. You know, some of your more simpler maintenance, if you can push it out to a cheaper contract service or hire lower level qualified mechanics, you know, in labor to take care of those, they're less likely to get sucked into the emergency repair kind of stuff that's pulling your resources away, you know, from doing those PMs in the first place. So it's just a matter of strategizing and figuring out how to use it. But the question is very good, because it's exactly the kind of thinking that I think you want to do, which is how do I use my PM compliance data to really start driving my organization to make the right decisions, to choose the right staffing levels, to give me the money to go and fix these problems and save money on the back end.
Great. I think we have time for a couple more here, and I apologize if we don't get to all your questions. We'll keep the dialogue going afterwards. But we have a listener asking Gil, how do you determine which tasks should be done by your machine operators, which type of PMs versus your maintenance staff? And any tips regarding, you know, work that is performed? You mentioned contractors, but even by your operators. Any rules of thumb about monitoring the PMs that are done perhaps outside of the maintenance department?
Yes. So another excellent question. So one of the things I tend to do is I always look at my dailies. Every organization has things that they need to happen on a daily basis. And my first approach to dailies is that I want to get rid of them. I don't want my expensive maintenance team working on dailies. Dailies are generally operational checks. Is the pressure high? Is the temperature high? Is the reservoir full? You know, things of that nature. In these checks, these surveillance checks are typically of the nature that an operator at the station can do. So I typically try to push dailies out to the operations team and let them own it. Then as a maintenance organization, what I do is I come in behind them and do a surveillance audit. One of my senior mechanics could perhaps audit several machines in a matter of a couple hours and know whether or not those operational checks are being done. What you want is eventually the synergy to be there, where that the operational checks that the operations team is doing triggers anything that needs investigation. So rather than have to go comply with 20 daily PMs, I might have to only deal with one investigative PM based on something that an operator saw. So that's one area to go look and try to push out to operations. It's not a blanket, all dailies have to go to operations, because there are some that do require skill, which leads me to the second part of the answer. I look and see what skill levels are required. If I have a highly skilled job, I want that, and I need to have a highly skilled mechanic or electrician or whatever the case might be, a millwright, to go do that job. I don't want that same millwright getting sucked into work that can be done by lower trained. And so I start to segregate my jobs by skill sets and by training requirements and by expertise. And then I try to push the lower level skilled jobs and the jobs that can be managed through other sources out to other groups, operations, contract services. And remember, in your CMMS system, it doesn't care who performs the work. I still want to have a work order, but the work order is going to get assigned. Remember that section in the slide that I had? You want to have who the craft is that the work is being assigned to. Well, in this case, maybe the craft is assigned to a contract services, and I list the contract service by name. In eMaint, we can auto-email that work order to that third-party contractor. They don't even have to be inside my firewall. So that's a simple way of handling third-party services. If it's another department, I just have to list them as my contacts and issue the work order to them instead of to myself. So there's a nice strategy that starts to unfold on how I structure the work. And ultimately what I want to do as a maintenance manager is I want to keep the most challenging and the skills, the highest skilled jobs to myself, so I can ensure that those are done properly, that they're not missed, that the quality is there, and that I can ensure that the people constantly receive the correct training. and I want to push my lower level skill stuff out as much as possible so that it gets done, it's routinely done, and my expensive people aren't getting pulled into that world.
That's a great guideline. Well, thank you, Gil, and thank you to all our listeners today. I'm afraid we are out of time at the moment, but I'm sorry I couldn't get to all your questions, but we really do want to keep the discussion going. So we have a very brief survey that we'll put up at the end of the webinar as soon as I end it. And please give us some feedback. Let us know how we did. Let us know other topics that are on your mind. We have Gil and his team here. What else? What other problems can they help you solve? How else can they provoke your thought process and help you on the path to improvement? So thanks again today to all of our listeners. Thank you so much, Gil, for joining us today, and we're thrilled to have you on the team. And again, to our listeners out there, thanks again, and we'll see you the next time. Take care.
Thank you, Rona. Goodbye, everybody.
Bye-bye.